So today's topic is going to be the last topic of the semester. It's perfect square trinomial by addition and subtraction. In this type of exercise, we will have a trinomial that seems to be a perfect square trinomial, but one of the terms is going to be incomplete. So the idea is to complete the perfect square trinomial by adding and subtracting the term that it's missing in order not to modify the algebraic expression. In this case, of course, imagine we have a specific algebraic expression. If I add something, I'm changing it or modifying it. So that's why I need to add it and also subtract it in order not to change the expression that I have originally. So in this case, step number 1 is going to be order the trinomial in order to have a perfect square trinomial structure. Number 2, it's going to be verify what is missing to complete the perfect square trinomial. We will need in step 3 to add that term in a positive and in a negative way, not to modify the algebraic expression. And then we will factorize it as a perfect square trinomial with difference of squares. So let's see the first example. On the first example, we have something like looks like a perfect square trinomial because the first term and the last term, the third one, have a specific square root, but the middle one, it's not 2 times the multiplication of both square roots. So in this case, we need to have these to be specifically the perfect square trinomial. So if I need those, that means what I'm missing, it's a plus n squared. But imagine if we are putting a positive one, we need to put a negative one also, not to modify the original expression we have. So in this case, it's going to be this one. So if we check here, this part, we can transform it or we can factorize it as a perfect square trinomial now. So it's going to be n squared plus 1, all of it squared, minus n squared. Then I have now what it's called difference of squares. So we can continue doing this one, and it's going to be, I will open up one bracket. Let me check. I will open up one bracket, and it's going to be n squared plus 1. And in the other one, it will be also n squared plus 1. Remember, the one that it's positive goes positive on both parentheses. The square root of the one that it's negative is going to be positive on the first one, negative on the second one. So we will have something like n squared plus 1 plus n. In the other one, we will get something like n squared plus 1 minus n. So if I order it correctly, it's going to be n squared plus n plus 1 that multiplies n squared minus n plus 1, and that is going to be our actual answer. So the idea, as I was telling you in the beginning, is we have something that looks like a perfect square trinomial, but something it's missing to have specifically the perfect square trinomial. So we need to add that term, but we also need to subtract that term also, because if I add the same term and subtract the same term, I'm not modifying the actual original expression. Then we will do it as a normal perfect square trinomial with difference of squares. So let's check another example. On this exercise, we have something like a to the 4 minus 6a squared plus 1. So how to do it in this case, it's going to be, remember, we need to have a specific structure of a perfect square trinomial. The specific structure of a perfect square trinomial should be a to the 4 plus 1, and in this case, the middle term of this one, remember, it's the multiplication of both the square roots, so it's going to be minus 2a squared. That's the structure of the perfect square trinomial. So in this case, I need to add plus 4a squared. And remember, if I add them positive, I need to put it also negative way. So it's going to be minus 4a squared. In this case, this one, it's going to be the perfect square trinomial. So we can factorize it as a squared minus 1, all of it squared, minus 4a squared. So now what I have here, it's a difference of squares. So I can do it like opening up a bracket, a squared minus 1, another bracket, a squared minus 1, because remember, the square root of the positive one, it's positive on both parentheses. The square root of the negative one, it's going to be positive on the first parenthesis, negative on the second one. So our answer is going to be a squared minus 1 plus 2a. And in the other one, it's going to be a squared minus 1 minus 2a. So if I order this correctly, it's going to be a squared plus 2a minus 1 that multiplies a squared minus 2a minus 1. And that's going to be our answer for this specific exercise. So let's check another time. The idea is that we need to convert our trinomial in the perfect square trinomial form. So in this case, the square root of a to the 4, it's a squared. The square root of 1, it's 1. If I multiply 2 times a to a squared plus 1, it's 2a squared. So I need to add plus 4a squared. If I add this one, I need to subtract it also. So it's going to be this one that has the specific structure of a perfect square trinomial. I factorize it as a perfect square trinomial. So I will have here what it's called difference of squares. So in that case, this one is going to be positive on the first one, and in the second one, the square root of this one is going to be positive on the first one, negative on the second one. And then I need to order my answer. So it's not difficult topic, it's only adding and subtracting what we are missing to have a specific perfect square trinomial. So let's see another example. So in this third example, also we have a trinomial. Remember, we need to convert that trinomial into a perfect square trinomial. So in this case, what I can do, I know that it's going to be x to the 4 and plus 100. So how to know the middle term? Remember, it's going to be the multiplication of this square root 2 times. So it's going to be 2 that multiplies x squared that multiplies 10. So it's going to be, what I need is going to be minus 20 x squared. So in this case, to get from minus 45 to minus 20, I need to add 25x squared. But if I add 25x squared, I also need to subtract it, not to modify the original algebraic expression. So in this case, it's going to be minus 25x squared. So this specific one, it's the perfect square trinomial. So I can factorize it as x squared minus 10, all of it squared, minus 25x squared. So in this case, I have here a difference of squares. So it's going to be, I open up a bracket, and it's going to be x squared minus 10. In the other bracket, it's going to be also x squared minus 10. And the second term, that is the negative one, is going to be the square root positive on the first one, negative on the second one. So I can continue doing it, and it's going to be x squared minus 10 plus 5x. That multiplies x squared minus 10 minus 5x. I need to order it correctly, and it's going to be x squared plus 5x minus 10. That multiplies x squared minus 5x minus 10. and that is going to be our actual final answer. So as I was telling you on the last exercises, it's not difficult. We only going to add what we need to have a perfect square trinomial, but we need to add them or also subtract them, not to modify what we have in the original problem. Then we will factorize it as a perfect square trinomial, and we will have a difference of squares here, and then we will have our answer. So let's see another example. So in this example, we have big numbers 36, 49, 109. So maybe it's kind of difficult to imagine which is the number we need on the middle term. So let's see how to do it. Maybe we can put here the corners 36 m to the 4. I know that this one is going to be negative, plus 49 m to the 4. And let's check out what we need. We will have from the first square root, it's going to be 6m squared. From the second square root, it's going to be 7n squared. That multiplies times 2. So in this case, it's going to be 7 times 6. It's 42 times 2, it's 84. M squared, n squared. So in that case, I need here to be 84 m squared, n squared. So let's see. From 109 negative to get minus 84, I need to add 25 m squared, n squared. And I need to subtract minus 25 m squared, n squared. So in that case, here I will put the minus 25 m squared, n squared. So let's check out. These three terms are the perfect square trinomial. So I can factorize it as 6m squared minus 7n squared minus 25m squared, n squared. So now I can put my two brackets. It's going to be the square root of the first one positive on both brackets, and the other one is going to be positive on the first parenthesis, negative on the second one. So it's going to be 6m squared minus 7n squared plus 5mn. That multiplies 6m squared minus 7n squared minus 5m, mn, I'm sorry. So we need to order it correctly, and it's going to be 6m squared plus 5mn minus 7n squared. That multiplies 6m squared minus 5mn minus 7n squared. And that is going to be our final and ordered answer. So if we have big numbers here, maybe to imagine the structure of the perfect square trinomial, we can do the multiplication of the square roots of the first one and the third one times 2 to check out which number we need here. Then we will need to add what we need here, and we need to subtract it also. Remember not to modify the original expression. Then we will have a perfect square trinomial. Then it will be here a difference of squares that we can factorize as we learned on the last topic. And in this case, we will have the correct and ordered answer. So let's see one last example. So in this specific exercise, we have something like this. So remember, we need to check out the specific structure we need to have a perfect square trinomial. So in this case, it's going to be plus 49 n to the 8. So it's going to be 2m to the 4. That multiplies 7n to the 4. That multiplies 2. So it's going to be 28m to the 4, n to the 4. So it's going to be here minus 28 m to the 4, n to the 4. So in that case, I need to add 25 again, m to the 4, n to the 4. I need to subtract it also, minus 25 m to the 4 n to the 4. So I need to put it here also. Then of course this one will be factorized as a perfect square trinomial. So it's going to be 2m to the 4 minus 7n to the 4, all of it squared, minus 25 m to the 4 n to the 4. So here I have a difference of squares. So the difference of squares is going to be, open up two brackets. On the first one, it's going to be 2m to the 4 minus 7n to the 4. In the other one, it's going to be also 2m to the 4 minus 7n to the 4. And it's going to be plus and minus. The square root of the second one is 7m squared n squared. The square root of the second one is 5m squared n squared. So our answer is going to be 2m to the 4 minus 7n to the 4 plus 5m squared n squared. The second one is going to be 2m to the 4 minus 7n to the 4 minus 5m squared n squared. So our final answer is going to be 2m to the 4 plus 5m squared n squared minus 7n to the 4. That multiplies 2m to the 4 minus 5m squared n squared minus 7n to the 4. And that will be our correct and ordered answer. So this topic, perfect square trinomial by addition and subtraction, it's not difficult. It's only adding and subtracting something that will complete my perfect square trinomial in order to do an exercise of perfect square trinomial with difference of squares. So after having my perfect square trinomial, it will be a perfect square trinomial with difference of squares exercise. So one last part, we complete the perfect square trinomial. Remember, we need to add and subtract the same term. In this case, this part can be factorized as a perfect square trinomial. This one I copied correctly like it is. So then I will have here a difference of squares. So it's going to be the square root of this one positive on both brackets, the square root of this one positive on the first one, negative on the second one. I only order it, and that's my final answer. So that's it. This one was the last topic of the semester, that it's called perfect square trinomial by addition and subtraction. Thank you for listening me.